For section D, which comprises of long answer questions of 5 marks each, we are going to attempt the first part of 32nd question. And we are given with the square matrix A of order 3. We have to find A inverse, and we have to use it to solve the following system of equations. So first of all, let's check whether A inverse exists or not. So we are going to find the determinant of A. And to find the determinant of A, let's expand it along row R1. Okay, so to expand it along row R1, so this is row R1. This is 1 into, if I remove, I'm going to pick up the first element 1 and remove the row and the column for this. So I'm left with this determinant of order 2. And after that, it has to be minus, then has to be multiplied with the second element. And if I remove the row and the column for the second element, I'm left with determinant 2 minus 1. So this is 2 minus 1 is 0 and 1. Okay, next is 0. So we are going to leave that. And now this is equal to 1 into negative 1, negative 2. So this is plus 2, 2 minus 0. So this is negative 3 plus 4, which is equal to 1, which is not equal to 0. So that means A inverse exists. Okay, now let me just write down here. So determinant of A is equal to 1, which is not equal to 0. So that means A inverse exists. And to get A inverse, this we know that A inverse is adjoint of A divided by the determinant of A. So now we are going to find out the adjoint of A, and for that we need to find the cofactor matrix. Okay, so we are going to find the cofactors of all the elements for A11, that is A11, and now we are going to find out adjoint of A. So adjoint of A, we are going to find out. So A11, remove the row and the column for A11. Now we are going to assign signs to them. So 1 plus 1 is 2, which is even. So this has to be plus. And if I remove the row and the column for A11, this is negative 1, negative 1, negative 2, 1. And this is now equal to minus 1, minus 2, which is equal to negative 3. So our first element of adjoint A is negative 3. And let's find out the other elements. So next element is A12. So A12, 1 plus 2 is 3, which is odd, so negative. And if I remove the row and the column for the second element, so I am left with 2, negative 1, 0, 1. So this is equal to negative 2. So this is negative 2, and I'm going to write it down. So just write down in this column. Okay, next is A13. So A13 is equal to 1 plus 3 is 4, which is over even. So this is plus. And if I remove the row and the column for the element in the first row and third column, remove this, we are left with 2. So 2, negative 1, 0, and negative 2. So multiply this. This is negative 4 minus 0, which is equal to negative 4. So write it down here. So we have got the cofactors of the first row, and in adjoint you have to write them in the column. Okay, let's move on to find out the cofactors of the second row, that is these. And we are, so the first one is A21, second is A22, second is third one is A23. And A21 is 2 plus 1 is 3, so negative, 2 is 4, even, so positive, 2 plus 3 is 5, odd, so negative. Now remove the row and the column for the respective elements and write down the determinant. So if I remove the row and the column, this is negative 2, 0, negative 2, 1. Remove the second row and the second column. So remove the second row and the second column. So if I remove the second row and the second column, this is 1, 0, 0, 1. So this is equal to, okay, now the third one is remove the second row in the third column. So second row and third column. So 1, negative 2, 0, negative 2, 1, negative 2, and 0, negative 2. Negative 2 into 1 is negative 2. So 1 into 1 is 1. 1 in negative 2. So we have negative 2, 1, and negative 2. Okay. So outside there is negative. So negative of negative is positive. So 2, 1, and this is also negative. So 2. So we have 2, 1, and 2. Okay, let's get the cofactors of, so this is A31, A32, and A333. 3 plus 1 is 4 positive, 3 plus 2 is 5 odd negative, 3 plus 3 is 6 even positive. Okay, removing the row and the column for the respective elements. So remove the row and the column for third row and first column. We are left with negative 2, negative 1, negative 1. Similarly, third row and second column. So this is third row and second column. So this is 1, 0, 2, negative 1. So next is third row and third column. So third row and third column, 1, negative 2, 1, negative 2, and 2, negative 1. Okay, so this is 2. This is negative, negative 1. This is 1. This is, okay, negative 1 and plus 4, which is equal to 3. So 2, 1, and 3. Now 2, 1, and 3 is the adjoint. And we have to find the A inverse. So A inverse is a matrix that we get after dividing adjoint of A with determinant of A. So determinant of A is 1 and adjoint of A is negative 3, 2, 2, negative 2, 1, 1, negative 4, 2, 3. This is adjoint of A. This has to be divided by 1. So that means A inverse is same as the adjoint, that is negative 2, 3, 2, 2, negative 2, 1, 1, 4, 2, and 3. So this is our A inverse, and we have to use this to find the value of, to solve the three linear equations. Okay, the last one is negative 4, 2, and 3. Okay, now our equations are x minus 2y is equal to 10, and this is 2x minus y minus z is equal to 8, and minus 2y plus z. So this is minus 2y plus z is equal to 7. Okay, now we have to write it in the form ax is equal to b, and x is now equal to A inverse b, and X matrix has the variables x, y, and z, and B matrix has the elements. This is the B matrix, 10, 8, and 7. So this is 10, 8, and 7. Okay, now let's replace the values here. So X is has the elements x, y, and z, which is equal to A inverse. So A inverse is negative 3 to 2, negative 2, 1, 1, and minus 4 to 3. So minus 4, 2, and 3. This matrix has to be multiplied with B, and B has elements 10, 8, and 7. So this is 10, 8, and 7. Now we have to multiply them. This matrix is of the order 3 by 3. This is of the order 3 by 1, and the resulting matrix should be of the order 3 by 1. So it should have 3 rows and 1 column. So first row with all the elements of all the column elements of B. So this is negative 3, into negative 10. So this is actually 10. This is 3 into 10. So 3 into 10 plus 2 into 8. 2 into 8 plus 2 into 7. Next row minus 2 into 10 plus 1 into 8 plus 1 into 7. Next is minus 4 into 10 plus 2 into 8 plus 3 into 7. Okay, so finally we have x, y, z matrix equal to, so this is 30, negative 30 plus 16 plus 14. 16 plus 14 is 30, so minus 30 plus 30 is 0. So this is 0, negative 20 plus 8 is negative 12 plus 7 is negative 5. So this is negative 5, negative 40 plus 16 and plus 21. Negative 40, this is negative 40 plus 16 plus 21. So 16 plus 21 is 737 and this is negative 3. So these two matrices are equal, and if we create the corresponding elements, so x is equal to 0, y is equal to negative 5 and z is equal to negative 3. This solves out the given pair of equations using the matrix method. Let's move on to part B of the same question.